Failure of classical theory to explain the Raman effect. According to classical theory, the light wave is nothing but the electromagnetic wave which have the electric vector and the magnetic vector. The electric vector of the light induces an electric dipole moment in the molecule which oscillates, giving the electromagnetic wave. So the induced dipole moment of the molecule is given by this relation as we have written here. Here nu naught is the frequency of the electromagnetic wave emitted by the oscillating molecule and nu the intrinsic frequency of the molecule. The terms this nu naught minus nu and nu naught plus nu, they correspond to the Stokes and anti-Stokes lines. If the intrinsic state of the molecule is not altered by the incident electromagnetic wave, then the scattered light will have the same frequency as that of the incident. So that gives the unmodified line. However, this theory has so many drawbacks. First is, in the classical theory, the single molecule gives the Raman lines that we have shown here. This is now anti-Stokes lines, these are the Stokes lines. It means that the single molecule is involved to give the Stokes and anti-Stokes lines. This is contrary to the experimental facts, which shows that a number of molecules are involved in the Raman scattering. In classical theory, the vibration or rotation of the molecule is essential. Boltzmann law gives that the molecules in the vibrational state are very low at ordinary temperature, and also their number decreases rapidly at the high frequencies. It means that the majority of molecules are not participating in the Raman effect, while experiment shows that number of molecules are involved in this Raman effect. So this is also contrary to the experimental fact. Third is, the classical theory has no idea about the quantization of rotational energy, which means that there is no possibility to calculate the intensity of the individual Raman lines. These are the such drawbacks which are against the experimental facts, and they cannot be this gives that the Raman effect cannot be explained by means of the classical theory. So classical theory